Good day, this is JT from Easy Math, a subsidiary of JT 8000 Pictures. Today we're going to be looking at real numbers. Under real numbers, we've got rational numbers and irrational numbers. Let's look closely at rational numbers. Under rational numbers, we've got natural numbers. Please pay attention at the way natural is written. You have 1 there. This means that natural numbers start from 1 and increase. The 3 dots means that we have omitted or left out many other numbers that are greater than 5, since this is the last number that we've written, such as 6, 7, 12, 15, 100, 1000, so on and so forth. We also have whole numbers. Again, please pay attention at the way the whole is written. You have 0 there. This means that whole numbers are natural numbers that start with 0. The 3 dots are for the same reason as before. And lastly, we've got integers. Integers are numbers from negative to positive or from positive to negative without a decimal. Now let's pay attention at the dots on the left. This means that we omitted or left out many other numbers that are less than -5, which is -6, -7, -15, -100, so on and so forth. And the dots on the right indicate that we have left out numbers that are greater than 5, which could be 6, 7, 9, 15, 18, 100, 1 million, so on and so forth. Now let's look at the difference between rational numbers and irrational numbers. Rational numbers, one thing you should know is that all integers are rational numbers. So the numbers that we'll be looking at from negative to positive, all those numbers are rational numbers. And because integers are rational numbers, so they cannot be associated with irrational numbers. If we write rational numbers as a fraction, both the numerator and denominator have to be integers. Okay, we can see that we've got 2 over 7 as an example there. 2 is an integer, 7 is an integer. But if we write irrational numbers as a fraction, that means either the numerator or the denominator is not going to be an integer, or both of them are not going to be integer. So here we've got the square root of 2 all over 7. The square root of 2 is not an integer because 2 is not a perfect square, but 7 is an integer. And because the square root of 2 is not an integer, this is an irrational number. The rational numbers, they terminate or end. They are not just continuous over and over again. There is a point where they end. Our example is 5.123. This number ends at 3. Okay, and irrational numbers, they do not terminate. These numbers are just continuous. You can see this is indicated by the 3 dots here, that indicating that these numbers are continuing. And then the decimal numbers have got a repeating single digit. It means after a comma, there is one number that is repeating itself. And here we've got the 3 after a comma. We've got a 3 repeating itself. And then here we've written it in a form that tells you that 3 is repeating itself. This is what we call 0.3 recur. This dot here, it shows that recur, meaning that there are many other 3's that we didn't write. Okay, and then with irrational numbers, there is no repeating single digit. So meaning after a comma, the numbers are just mixed up. Here you've got 2 of the 5 that are repeating, but this cannot qualify as an rational number because there are only 2 of them. For it to qualify as a rational number, there has to be more other 5 after that. The rational numbers, we've got recurring multiple digits. That means there is a pattern after a comma for the number, for a certain numbers. And here you can see we've got 2,4141414141. It means that the recurring multiple digit is 41414141. And here we've written it as a 4 recurring, 1 recur. It means that the 414141 is repeating itself. And then here you have written it as a bar. So this is 2,41 bar, meaning that 41 is repeating itself. With irrational numbers, the decimal numbers do not have recurring multiple digits. That means after a comma, there are no certain digits that are repeating itself in a certain way. So here you can see that we've got 2,4564187. So there's no one number that is repeating itself, and there are no multiple digits that are repeating themselves. Now let's look at examples. We need to identify the following as rational or irrational number. So now let's look closely at them. We've got 5,1762103, and these numbers keep on. Okay, we have omitted other numbers from this number. First, for it to be a rational number, you have to have one digit that is repeating itself. There's no one digit that is repeating itself. There has to be multiple digits that are repeating themselves in a certain pattern. There's no such. This means that now this is going to be an irrational number. The second one is 0,21212. Again, we've got 3 dots showing that there are many other numbers that you didn't write. But now let's look here at the numbers that we have. We've got 0,21212. That means the next number here should be 1, because you can see there's a pattern of repeating multiple digits. So this qualifies as a rational number. And then we've got -5/12. Now let's look at both numerator and denominator. -5 is an integer, 12 is an integer. This means that this is a rational number. Now the square root of 39. 39 is not a perfect square. Therefore, the square root of 39 is going to be an irrational number. Pi. Pi, is it a rational number or irrational number? Pi is not 3,14. There are many other numbers that were not written after that 4. Okay, so pi is an irrational number because pi is not 3,14. 0,75 bar. The bar means that these numbers are repeating themselves. This means that you're going to have 0,75, 75, 75, many other 75, but we didn't want to write all of them, so we write 0,75 bar. So this means this qualifies as repeating multiple digits. This is an irrational number. Okay, the square root of 11/8. 11 is not a perfect square. It means that the square root of 11 is not an integer. Therefore, the square root of 11/8 is irrational. Okay, now here's an activity for you to do. Please pause the video, do the activity, and then see if the answers are the same and where you went wrong. Okay, the first one is 5,135,135,133 dots, meaning that we have left out other numbers. But let's look after a comma. We've got 135, 135, 13. That means